Hi guys, so one of the questions I've had is how do we know whether one of the methyl groups is part of the carbon chain or not? And another question was how do we identify the different R groups to classify alcohols as primary, secondary or tertiary? So I've got 4 examples of different alcohols to illustrate this and hopefully answer those questions. So first thing you'll need to be able to know is how to name different alcohols. So you'll have to have done the IUPAC naming system to begin with. So you should be aware that prop means 3, but means 4, and then here the number at the start, that's telling you the position of the methyl branch. So this methyl group here is a branch that's coming off the carbon chain. So it's not part of the parent chain, the longest chain, it's a branch that's coming off. What we're going to do is use the name and the structural formula to draw the compound as displayed formula, which is all atoms, all bonds showing. Now the structural formula shows you the number of each type of atom present, and it shows you the order in which they're bonded. So if we have a look at the displayed formulae, we have CH3, CH2, CH2 and then OH. So we draw it in the order we see it from the structural formula. Same with propan-2-ol, CH3, CH, OH. Now it doesn't matter if the OH is on top and the hydrogen's on the bottom, because single bonds rotate, the molecule flips. It's a 3D molecule, it doesn't make any difference. And then CH3 on the end. Then for this one, CH3, COH, that's this one. We have CH3 in brackets and a 2 outside. Now the reason we would know what to do with this is because carbon can only form 4 bonds, hydrogen forms 1, and the only way to satisfy that is to put a methyl branch here, CH3 branch, and a methyl group as part of the carbon chain here. And if we look at the name, it's a prop, so we have to have 3 carbons in the chain, and it says there's a methyl branch on carbon number 2. Then the last one, 2-methyl, this "-ile" tells us there's a branch. The meth bit means 1 carbon, so 1 carbon branch. Here's our carbon branch. But 4 carbons, 2-ol, the alcohol group is on carbon number 2. Now I've done something different here just to illustrate a point. So I told you that with structural formulae you draw it in the order it's written, so CH3, COH. So I've done it from the opposite side, so CH3, COH, CH3 in brackets, that's a branch, CH2, CH3. Now this is correct, and it would be correct if you drew it the other way around, because that is the exact same molecule, just flipped. So molecules are 3D, they can flip, and it is the exact same structure. And the last thing I'm going to explain in this video is how to classify alcohols as primary, secondary and tertiary structures. So you might be given a name of an alcohol and asked whether it's primary, secondary or tertiary, or you might be given the structural formula or the displayed formula and asked. If you're given anything other than the displayed formula, it's useful to draw the displayed formula first, then you can actually see the alcohol and it's easy to figure out which one of those it is, primary, secondary or tertiary. So primary and secondary and tertiary, it's about how many carbon chains are around that alcohol group. If we look at the first example, ethanol, it's right on the end, so all of this counts as 1 carbon group attached, so it's primary. If we look at the next one, propan-2-ol, we can see this alcohol is surrounded by 2 carbon chains. So CH3, CH3, this doesn't count as one of the R groups. So we've got 2 and it's secondary. If we look at the next one, 2-methylpropan-2-ol, we've got 2 carbon groups here and another one here. Doesn't matter whether these carbon groups are the same as each other or different, there are still carbon groups surrounding that OH. We've got 3, so it's tertiary. And the last example, 2-methylbutan-2-ol, we've got 1, 2, 3 carbon groups around that alcohol.